This is quiz 18, and once again we're still finding derivatives, and again we're using the chain rule. So in this case we're finding the derivative of, well, I guess this was where we had an introduction to the logarithm function and its derivatives and logarithmic differentiation. So anyway, the first one, the function is y equals the natural log of the sine squared of x, and we want to find dy dx. So y prime, or dy dx, is going to be the derivative of the log, and the derivative of the log of anything is going to be 1 over that anything. So we just write 1 over whatever is inside the log. But then we have to take the derivative, and I'll write it out in longhand this time, times the derivative of what's inside. So that's the derivative of the sine squared of x. And to take the derivative of this, we have to remember that the sine squared of x means the sine of x quantity squared. So this is 1 over sine squared of x. And now the derivative of anything squared, that's what we're looking at, is up here. The derivative of this is going to give us 2 times whatever that thing is, which in this case is sine of x, to the first, which I don't have to write. But then the chain rule comes in and says, oh, you got to multiply by the derivative of what's inside, so we get a cosine term. And this we really do have to simplify, because obviously sines are going to cancel here. And so you're going to be left with 2 cosine of x divided by sine of x. And that's good enough. You can leave it that way. Or if you prefer, it's 2 cotangent of x. But this is perfectly okay. All right, the next problem, number 2, is a bit more involved. This we have to use logarithmic differentiation. Now folks, if the problem says you have to use logarithmic differentiation, you really have to use logarithmic differentiation. So you need to review how that works. So in this case, the problem is find the derivative, y prime, where y equals x to the sine of x power, using logarithmic differentiation. The idea with logarithmic differentiation is that we first take the log of both sides. If these things are equal, then their logarithms will be equal, and therefore the natural log of y will be equal to the natural log of x to the sine of x power. But the beauty of doing the log here is that logs play very well with exponents, and so this right-hand side is just going to be the sine of x times the log of x, because the log of any exponential expression makes the exponent come tumbling down as a multiplier. And so we end up with that sine of x on the outside times what's left is just log of x. So now I'll just rewrite the equation that I'm looking at. I'm looking at this equation, log of y equals sine of x times log of x. And now I take the derivative of both sides with respect to x, because the problem is find dy dx. So x is the independent variable. Okay, so if I take the derivative on the left, this is the natural log of y. The derivative of the log of anything is 1 over that anything. But the chain rule says, since this is not x, and you're taking derivatives with respect to x, you got to multiply by the derivative of what's inside, and the derivative of y will be dy dx, because y is a function. On the right, you have to take the derivative of this thing. And how do you do that? Well, it's a product, so you have no choice. You have to use the product rule. So it's the first times the derivative of the second. The derivative of the log is 1 over whatever. And here we've got just x, so the chain rule doesn't have to say anything. So that's first times derivative of the second plus the second, which is log of x, times the derivative of the first, which is cosine of x. Derivative of sine is cosine. And on the left, whenever you use logarithmic differentiation, and this was y to begin with, you'll always end up with log of y and then 1 over y dy dx, so that your final answer is going to be dy dx equals, and then this 1 over y, you move over to the other side as y. So it's y times all of that. Sine x, I'll write this as sine x over x, save a little bit of space, plus log x cosine x. And then one last substitution, and that is that dy dx is y, which was originally x to the sine x power, multiplied by all the rest of that stuff. Sine x over x plus log x cosine of x. And notice that the derivative of any exponential, including something as nasty as this, is that exponential back again, but then times a bunch of crud. And so you really do need to go through something like this in order to calculate. So you should be able to calculate derivatives of any exponential. So like sine x to the cosine of x power, I think that might have been one of the homework problems. You need to be able to do things like that. And it's always the same thing. You take the log of both sides, just like we did here, and then the log will tear apart that nasty thing and turn it into a product. Then you can use the product rule. And then on the other side, you'll always have 1 over y dy dx when you take the derivative, and that allows you to push the y to the other side, the original function times a bunch of other crud. Okay? And that's it for quiz 18.